with Dr. VanderWaal. Thank you.
All right, thank you. So I'll try to be on time because I know everyone's getting a little bit antsy. I want to start by recognizing all of the institutions and the partners that made this work possible, especially in terms of the field work and the lab work, which I was not involved with either of those stages. And they include the Directorate for FMD in India, as well as the USDA Agricultural Research Service at Plum Island. And then I am from University of Minnesota, and I want to recognize my, my colleagues there, Dr. Andres Perez and Shivdeep Hire, who is the man pictured here, who's a PhD student in our lab, and he was responsible for most of the analyses I'm showing today. So just very briefly, FMD is endemic in India, and they have experienced more than 2,000 outbreaks over the past 5 years. And the objective of this research was to study the transmission dynamics during an outbreak and the length of the carrier stage post-outbreak in natural conditions in a vaccinated dairy herd within India. So I'm actually talking about 2 different outbreaks today, and I'm just putting them on a map here to kind of show you how that these are, these are quite distinct areas of India. So these are unrelated outbreaks. In the first outbreak, in this more central part of India, we'll be focusing on the within herd dynamics. And then in the second outbreak, which is actually 2 farms that are close together, is where we did the longitudinal sampling. So just a brief context on outbreak number 1. This outbreak occurred in a large dairy consisting of about 1,800 milking cows located in Chhattisgarh, India. And this was a serotype O outbreak. It's happened in late December, and this period, or the outbreak lasted about 36 days. And all of these animals had been vaccinated approximately 47 days prior to the outbreak, and then had been routinely vaccinated prior to that. So in this study, our goal was to use some great data that was collected by this team to estimate the transmission coefficient, beta, for this outbreak under the context of vaccination. So we had the daily incidence of clinical cases within this farm, which is what is pictured here. And this provides a really interesting opportunity to look into transmission coefficients, because a lot of our understanding of that comes from lab experiments. So we fit a SEIR model to this data. In this model, all individuals in the population could be classified in one of 4 compartments: susceptible, exposed, infected, and here we're referring to clinically infectious animals, and recovered. And they transition between these compartments based on what we know about the virus, and then there's a few parameters that we were trying to estimate, which is the transmission coefficient here, which mediates the rate at which animals move from susceptible to exposed. And then we also looked at vaccine protectiveness here, where some animals, a certain proportion, will leave the exposed compartment and go directly to recovered without experiencing clinical infection, and then the remaining proportion will go through a clinical infection stage. And we fit a couple different iterations of this model because there was a few things that we were wanted to be flexible with the way we interpret it, especially in terms of the lengths of the exposed period as well as the lengths of the clinical period. And then we also had a version of the model where we split up the exposed period into a true latent period as well as a preclinical period where animals could transmit the disease at that point. All right. So our results, we found that the vaccine protectiveness was about 88%, indicating that about 88% of the animals did not experience clinical infection. And we found that the transmission coefficient, assuming frequency dependence, was 38.1, which means that any infectious animal would make contact sufficient for transmission to occur with about 38 animals per day. And I also put the density-dependent assumption there as well, and the transmission coefficient for that, just for sakes of comparison for those interested. And what you're looking here down here is the cumulative incidence of clinical cases, with the black circles representing the actual observed cumulative clinical cases, and the dotted line represents our fitted model, and then the gray shaded area represents the confidence or the prediction interval. So we actually feel like we got a very, very good fit to the dynamics of the disease. In the second section of this talk, I'm briefly going to go over the post-outbreak dynamics work that our team did. And just to give you a little context, this was an outbreak that occurred in 2 adjacent farms in Mukteshwar, India. These farms were approximately 1 kilometer apart, and they experienced an outbreak within, I think, 5 days of each other. And so we do think that these 2 farms did experience the same strain. And these farms had just recently been vaccinated as well. Farm A consisted of calves, steers, and heifers ranging in age from 1 month to 2 years. And then Farm B consisted of lactating cows 2 years and older. So the purpose of this study was to look at the dynamics of the carrier stage post-infection in these vaccinated animals. So in this portion, 78 carrier animals were sampled monthly from 6 months post-infection to 23 months post-infection. And they were sampled both by probang and blood. And the presence of the virus was looked for in oropharyngeal fluid by multiplex PCR and RT-PCR. And also the blood was screened for NSP antibodies. So, and we define the carrier state here as, or the extinction of the carrier state is when these animals had tested for 4 consecutive months as negative to both multiplex PCR and RT-PCR. And that's because a lot of animals would transiently kind of move in and out of being positive. So we want to make sure that once they went to 4 months, they consistently stayed negative after that. So we looked at this data with a survival analysis, and we found that the average length of the carrier stage was approximately 13 months in both farms. And we also stratified the data by looking at animals that were asymptomatic during the actual outbreak, as well as animals that had been clinical during the outbreak. And there was no significant difference in the persistence of the carrier stage in those animals. We also looked at the titers to NSP over time, and what you're looking at here is Farm A and Farm B, and the main take-home message here is that here we go from 6 months to 23 months, and these black bars, the vertical bars, represent times when the herd was vaccinated. And after each vaccination in both farms, we see a transient increase in the titer, suggesting that there were some impurities in the vaccine. And I guess my main comment here would be that NSP ELISA results should be interpreted in the context of vaccination, as has been suggested elsewhere. So in conclusion, the transmission rate of serotype O in vaccinated dairies was approximately 38, and 88% of the animals were protected from clinical infection through vaccination. The persistence of the carrier state was 13 months on average, and impure vaccines can transiently increase levels of non-structural proteins. And thank you for your attention.
Thank you very much, very interesting. Any questions? Question here.
First, it was a very interesting presentation. Thank you. When you are talking about the 88% vaccine protectiveness, how do you know it's related to the vaccine? Maybe just, maybe without any vaccine, only 12% of the animals would have been infected, or I did not get here something.
Okay, so that number was based on that once animals were exposed in the model, they could either proceed in the kind of the path directly where they skip the clinical infection stage, or they could go through the clinical infection stage. And we actually fit that with maximum likelihood on what would that value be for the model to fit the observed data as close as possible. Does that get at your question?
No, but I will catch you later.
Okay.
I guess the thing with this is, you have to you're kind of assuming that all animals are equal risk of exposure, and that's quite a a big assumption. When you're saying that 88% were protected, well, you're assuming there that 100% were exposed, or you have to make an adjustment in statistically for that, which I think is possibly what you're guessing at.
And also some of the exposed may not succumb to clinical disease without relation to vaccination. I mean, they may be subclinically infected without vaccination. So.
That's true. That's possible. So maybe it'd be more accurate to say that 12% did not become clinically infected either because of vaccination or another reason. But my understanding from talking to the collaborators who actually were doing the work on the farm is that these animals were managed as a single unit, and it wasn't like some of the other presentations we've seen that had a lot of structure within the farm that may really affect exposure.
I guess another issue is, sorry, obviously we're on the same page with this, because how about previous exposure? The origin of these animals, they could have been exposed to disease before and been protected because they've been exposed to virus before. Nothing to do with vaccination. Did you have any knowledge on the history of that?
I'd have to ask my collaborators on the history of the animals.
Okay. Eyal, do you want to follow that up?
If no one else wants to ask.
Okay. Well, Eyal, ask your question, because you have the microphone in your hand, and then we'll go to the other question at the back.
So first, I wanted to say that the follow-up after the subclinically infected is extremely interesting. And just want to mention also that the your NSP results, despite the impurity of the vaccination, the NSP antibodies stay for much shorter period than what we saw in Israel. So I wonder what is the reason for this, because it was, I think, just at 18 months they were almost gone. And in Israel we looked at them for 3 years and they were still positive, as I showed before. So do you have any,
Well, I know there's been other work elsewhere in, I think, Cameroon, where they were looking at waning antibody rates in cattle there, and they found large differences among, I think they were just based on different serotypes, so not strain level differences, but in terms of the length that you would expect that NSP would persist in terms of being reactive to NSP. So I can't speak to the exact strain level differences between your study and this study, but I think that there's evidence elsewhere that it's not the same for all strains.
Okay, I've been told by the boss that we have to stop, actually. So, but we can continue the discussion afterwards, hopefully. But thank you very much.